Hello and welcome back to the channel. In today's video, I'm going to be talking about the Year 2 SATs, and specifically the arithmetic test that the children have to do in their Year 2 SATs. This is down to the fact that on the channel, a video of the 2019 Year 2 SATs arithmetic test has had a lot of views. It's very popular, so I wanted to do a new video on this. And this is looking at the questions that came up in the 2022 paper to help your child prepare for their Year 2 SATs this year. Okay, so when are they taking place? Well, the Key Stage 1 SATs, also known as the Year 2 SATs, take place during the month of May. Now, what that means is the school, unlike the Year 6 SATs, where there's a specific date, they can decide any time during the month of May when they want the Year 2 children to sit those SATs. Now, there's also another reason why it's for an entire month, and that is because with the children being younger, often schools like to do the tests over a longer period of time and get the children to do it in small groups. And that's so that they can best support the children, because, as you know, the children in Year 2 are still very young, and to get them to sit a test is quite demanding of such young children. So there you can see this was taken from the government website that they say that the Key Stage 1 test period is in May 2023. You can just also see there the date for the phonics assessment, which is another assessment that children do during Key Stage 1. Okay, so that's when it is. So if you're looking to prepare your child for these SATs, that's the date you're sort of working towards. All right, so I'm going to start off by going through the questions chronologically. It is a walkthrough, so I'll go through every question on the arithmetic paper, and I'll show you the methods that we teach in school to help the children to solve these questions. The first question they'll see is a practice question, and they're most likely to go through this question with the teacher. Now, this is a Key Stage 1 assessment, which means they're tested on knowledge and learning that they've got from Year 1 and 2. The first few questions on the paper will feel and seem easier because that's testing them on knowledge they've gained in Year 1. So this is one of those questions. 3 add 2. This is just testing their ability to add two one-digit numbers together. Now, realistically, hopefully your child would be able to count on from 3 and basically count on 2. So 1, 2, 3, starting at 3, 4, and getting to 5. So that's a very straightforward question, and hopefully most children can attempt that question. So straight in then, page 1, okay, these questions are taken from the SATs paper. Again, we've got a fairly simple question. This is 3 add 7. Now, this question is here because it's testing the children's ability on their number bonds to 10. So the number bonds to 10 are 1 and 9, 2 and 8, 3 and 7, okay, 4 and 6, 5 and 5, and so on. Now, they need to know what these are, and they need to know them pretty sharp, pretty quickly. So 3 add 7 make 10. Now, even if they don't know, they should be able to count on from 7, putting 7 in their head and counting on from their 8, 9, 10. Okay, so that would be the answer, and the children must write the answer in the box provided. 100 take away 1. This, again, is just assessing their ability to count backwards. So starting from 100, they should just be able to count back 1 and get to the number of 99. Now, I won't be going through and showing methods for every single question because some of these questions are fairly straightforward, and it's just testing the children's ability to count forwards and backwards, and there isn't a necessity for them to write anything down. Okay, so now on to a couple more questions. Page 2 of the test. 33 add 10, okay? So this is assessing the children's ability to count on in 10. So they could attempt this by drawing a number line and then doing one big jump of 10 and getting to 43. So that is one way of doing it. Another visual that they could use is starting with their tens and ones grid. So tens here, ones here. And this is where we would have taught that in school, they would create their big number first, which is 33. Okay, that's 3 tens and 3 ones. And then just by drawing an extra 10 in the tens column, because we're adding 10, okay, you can now count 10, 20, 30, 40, 1, 2, 3. So there's two different ways that your child could do it. They will have been taught a couple of different ways and then they can choose which way they feel most confident and comfortable with. 19 subtract 3. This is, again, two different ways of doing it. One will be the number line. This time, to draw a line, start with 19 at the end. I'm going to count back. So we're counting back 3 ones. They could do it in one whole jump of 3, or they could do 3 jumps of 1. So minus 1 would be 18, minus 2 would be 17, and minus 3 would be 16. Okay, so it's completely up to them which way they do it. And once again, they could draw a tens and ones grid like I've done here, drawing the 19 out. Okay, so you've got your tens and ones. Make the number 19. That's 1, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then once you've made the 19, crossing out one of those ones, okay? And then what have we got left? Sorry, crossing out 3 of those ones. And what have we got left? We've got 10, 11, 12, 13, 14, 15, 16. And you should see that we've got the same answer. Okay, but again, 2 separate ways of doing it, whichever way your child feels confident and comfortable doing it. Okay, on to the next question. So this is page 3 of the test, and we've got questions 5 and 6. 5 is an addition question, 67 add 2. And once again, I would recommend drawing a number line for this, starting at 67. Okay, now some children may be able to just put that number in their head and count on 68, 69. But they could also, if they like to, okay, draw out the number line. Add one, we've got 68. Add another one. We've got 69. Okay, they may be able to do it in their head. Another tricky thing about this question is that the sum is here and the equal box is here. Okay, just the way it's laid out. Sometimes the children are used to seeing the number, the larger number come first. But they need to know that with these numbers, you start with a larger one and you add on this smaller one. To add 67 to 2 would be a bit more tricky doing it that way. So writing our answer in the box. Okay, now we get our first multiplication question. Now in year 2, the children should know their 2s, 5s and 10 times tables, and then possibly also the related division facts as well, and possibly some of the 3 times table, but definitely they're 2, 5s and 10s. So this is the first question. You can see that it's come from the 2 times table, 2 times 7. Now in year 2, they are taught that this symbol here, which yes means multiplication times, but it also means groups of. Okay, so why do we tell the children it means groups of? Well, because if they know that symbol means groups of, they can then read this as 2 groups of 7, which then links nicely to a method that they're taught in school. Okay, nice pictorial way of showing it. You've got 2 groups, and then inside 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And then once they've made their 2 groups of 7, so you've got 7 in that one and 7 in that one, okay, then they can count 7, 8, 9, 10, 11, 12, 13, 14. And if they don't know their 2 times table off by heart, there's nothing wrong with them drawing it out this way in order to solve it. So we have page 4 of the test, which is questions 7 and 8. And we've got another multiplication question, and we've got an addition question. So 10, again, this symbol, like I said before, means groups of, 10 groups of 5. I have seen children drawing out the 10 groups and then putting 5 in. Or you could do 5 groups of 10. It's quite long-winded. There's nothing wrong with them drawing the groups out. But you'd expect the children in year 2 to be able to count in 10. So what I would probably say for this question is if they can, just to count 5 tens. So 10, 20, 30, 40, 50. Okay, and that will be our answer. Again, there's nothing wrong with them drawing the groups, but a quicker way would just be to count up in tens if your child can do so. Okay, we've got 30, add 50. Now for this question, I've seen some people say to the children, well, add 3 and 5 together, that makes 8. And then add the 0, which makes 80. But you're teaching the children a rule without a reason there. And what they really need to know is the understanding behind that. So there's nothing wrong for this question with them drawing a tens and ones grid so they can see what they're actually adding together here. It's not 3 add 5. It's actually 30 add 50. So we're going to put the 50 first, 10, 20, 30, 40, 50, because I would always encourage them to start with a larger number, even if it comes second in the number sentence. And then we're going to add 3 more 10s, because it's 30 is 3 10s, 10, 20, 30. Now we can see we've got 5 10s, add 3 10s, that's going to be 5, 6, 7, 8, 8 10s, which is 80. So, yeah, they could add the 5 and 3 together and then add a 0, but it's not really showing them the understanding of what they're actually adding here is 30, 3 10s, and 50, which is 5 10s. Okay, on to the next question. Right, so the next question is page 5 of the test, question 9 and 10. And we've got a subtraction question here, and this time the children are being asked to subtract a multiple of 10. Now, what they could do is they could draw themselves a number line, which is one way of solving it. Start with 41. Whenever we're subtracting, it must go at the end, and then do one big jump of 10. Okay, now we're taking away from the 10s, so that would be 31. All depends on a method that your child is comfortable with, but you could also do the 10s and 1s grid again. And they could draw out the large number, 10, 20, 30, 40, and 1. By the way, these lines are 10s, and the children would recognize them as 10s because they use something called deans. And deans are basically long lines of 1s. If you've never seen them before, I'll put an image of them just here so you can see what they look like. But yeah, that's what these lines are and why they represent 10. So 10, 20, 30, 40, 1. And we're not touching the 1s because we're taking away 10. There are no 1s to take away. So we're going to cross out 1 10. Okay, and the children will have been taught to do this in school, hopefully, which leaves us with 10, 20, 30, and 1, 31. Okay. And, we've got a division question here, number 10. I think this is the first division question on the paper. 15 divided by 5. Now, in a similar way, how we teach the children the times sign means groups of, this division sign we teach them means to share, okay? And when you're teaching younger children, always giving them a real life example. So let's say that our friends have got 15 sweets, and there's 5, they want to share them between 5 friends. Okay, so what we would teach them to do is draw 5 groups. So we're sharing into 5 groups. 15 shared into 5 groups. So the children would draw out the groups like this, and they're perfectly okay to do this during the test. And then you share, and by the way, this means share equally. Okay, I should have said that earlier. Yeah, share equally, this division sign. So 15 shared into the 5 groups. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And what the children should be learning is that when you're sharing these out, okay, the answer is going to be how much one person would get. If you share them equally, what is it in one group? So here you can count one group, 1, 2, 3, and that would give us an answer of 3. So that is the method we would teach them in school. And we would teach them that symbol there means to share. Okay, let's move on. Question 11 and 12. This is page 6 now of the paper. And we've got our first 2-digit and 2-digit addition. And we've got our first fraction question. So let's do this one first. Now, for this, I would encourage all the children to draw a 10s and 1s grid. Not that you can't do it on a number line, but I just think this method is clearer. So 31 add 46. Now what I would say to children is make the larger number first. Even if the smaller number comes first, make the larger number first. So we're going to do 10, 20, 30, 40. And we've got 6 ones. 1, 2, 3, 4, 5, 6. And now we're going to add to that, we're going to add 3 10s and a 1 for 31. So we're going to add 3 10s, 10, 20, 30, and we're going to add 1 into the 1s column. So what does that leave us with? Now you ask the children to count at the 10s, and this is the way I would suggest they do it. 10, 20, 30, 40, 50, 60, 70. Write it down here. And then count at the 1s. 1, 2, 3, 4, 5, 6, and 7. And then the last step is to add those 2 bits together, giving us a final answer of 77. And make sure the children are encouraged to write their answer in the box. So that's using a tens and ones grid to help solve that question for Year 2 children. Okay, so a half of 80, our first fraction question. Now, this is what's called a fraction of amount question, because we're basically wanting to know if I had 80 sweets, again, putting it into a context that children would understand. If I had 80 sweets and I wanted to half those between me and my friend, what would each of us get? Now, one way we do show the children is that it's similar to division in that that number there, the denominator, is telling us how many groups we need to share that 80 in. Now, it would be not impossible and for a child to do 80 and share them into the groups. Is it the most efficient and quickest way? I don't think so, but I have seen children do it in the test and get the answer correct. But if they do have to share out 80, there's a good chance they can also make a mistake. So that is one way, but I wouldn't encourage the children to do that. I would probably say to the children, if we have 80 and we partition that number into 2, so let's just partition that into 4 and partition here, we've got nothing here. And that's not actually 4. I would say to them, well, that's 80. You've got 8 tens. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Now, if you were to split those 8 tens and share them between 2 people, okay, how many would each person get? And the answer is that we'd each get 40, okay? And they can check that by drawing the 8 tens out and just halving them. So drawing a circle around half, if you will, and they can see that that's 10, 20, 30, 40. Okay, so that's one way of solving that question. Yes, they can do it by drawing the groups, but it's not the most efficient or quickest way. Okay, let's move on. Okay, so on to page 7, and we are on to question 13 and 14 of the paper now. Now we have a 2-digit and 2-digit subtraction, but actually what we're doing here is we're actually just taking away tens. But again, I would recommend drawing the tens and ones grid. You could get them to do a number line and count back in tens. That method would work also. But here I would probably encourage my children to draw a tens and ones grid. Make the largest number, so that's 10, 20, 30, 40, 50, 60, and 7 ones. 1, 2, 3, 4, 5, 6, 7. And then we are taking away 4 tens. So I would get them to then cross out, okay, 4 tens, actually crossing it out in pencil so they can see they're actually getting rid of those. And then counting how much left over do you have. So you've taken away 4 tens, they're gone. You've got 2 tens left, 10, 20, and we haven't touched the ones. So we've still got 7 ones, leaving with the final answer. Oops. Best for them to write it underneath just so they don't forget to add those bits together. A final answer of 27. Okay, so question 14 is slightly different because there's a box here. It's not come at the end of the number sentence, which sometimes confuses children. But what I would teach children is that this equal sign here is like a weighing scale, a balancing scale. Okay, and that anything on this side has to equal the same on this side. Okay, so you've got 17 here. 8 and 4 and something have to equal 17. So whatever it is in this box, okay, whatever it is that you put in this box, 8 and 4 and whatever goes in here must equal 17. So what you can do is you can say to the children, well, to find out I could do the inverse. So I could do 17 take away 4, which is 16, 15, 14, 13, okay? And then you could do 13 take away 8. All right, might be best to do one small jump of 3 to make it to 10, and then do another jump of 5 to give you 5. So 13 take away 8 is 5. Now I've taken away the 4, I've taken away the 8. Does 5 make sense in that box there? If I add 8 and 4 together, okay, that makes 12. And what would I have to add to 12 to get to 17 so that that is equal to that? I would need to add 5. So 5 does fit in there, and it is the correct answer. Okay, so 2 different ways of doing it. 1, the inverse, and 2, by adding the 2 numbers together that you do have and seeing what you need to add to that number to get to 17. Okay, let's move on. Okay, question 15 and 16. This is page 8 of the paper. We've got an interesting question here, 100 divided by 10. Now, you would never teach the children really in year 2 about the place value chart. The tens and ones grid you would show them, but not a place value chart where you're moving the numbers backwards and forwards. So what they're basically doing here is if you had 100 and you share that out between 10 friends, how much does each friend get? Now, you could get, the children might try and draw 10 groups and share out 100 into those 10 groups, but that would be an extremely long-winded way of doing it. May work for them, but here, what this is actually testing them is their knowledge of their division and multiplication facts. So, if you know that 10 times 10 is 100, then the children need to know, and this is why it's so important when learning the 10 times table, not just learning to count in tens, but also the related facts, is that if I bring 100 to the front here, and I do 100 divided by 10, and I share 100 between 10 friends, I'm going to be left with 10 for each of them. A very tricky question. A lot of children would try and draw the groups and probably get it wrong, but that's why it's so important to teach your children the related division and multiplication facts. Okay, so next question. We've got another add two-digit number. And the interesting thing about this one is just looking at these numbers, I can tell that we're going to be making a new 10 here because 8 and 2 makes 10. So what you say to the children is you say first draw your tens and ones grid. Then you want to draw your biggest number first. So 10, 20, 30, 40, 50. And then, so that's 58. And now I'm going to add to that 32. So start with the tens, 10, 20, 30. And then we're going to add 2 ones. Now, what you need to show to the children now is that what you've actually done here is you've made a new 10. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to draw a ring around my new 10 that I've made because they need to know that you've made a new 10 and that 10 would now move into the tens column, meaning that we have got 10, 20, 30, 40, 50, 60, 70, 80, 90. So the answer to this question would therefore be 90. And that's the way that we would show the children how to solve it. Okay, moving on. Next question, we've got 17. Once again, another question that's going to involve the tens and ones grid. And once again, we are going to be making a new 10. So, draw my tens and ones grid out. 45, make the larger number first. 10, 20, 30, 40. 1, 2, 3, 4, 5. That's first step done. Now make the smaller number, adding it on. So 16 is 110. And then 1, 2, 3, 4, 5, 6. Now, once again, if we look at this, we've made a new 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to get the children to draw a ring around the new 10 that they've made. And I'm going to get them to draw an arrow showing that that should now move into the tens column. However, we are left with 1 in the ones column. So 10, 20, 30, 40, 50, 60. And then we've got 1 over here. Don't forget that. That 1 was left over, leaving us with a final answer of 61. Okay, so on to our next question, 18. A fractions of amount question, another fraction of amount question, right? So, a quarter of 16. Now, what we teach the children is that number there, the denominator, is telling us how many groups that I want to share the 16 into. So, it's like we've got 16 sweets and we're sharing it between 4 friends. That's what finding a quarter means. So, I'm going to draw 4 groups. 1, 2, 3, 4, and the children should do this on their test paper. And then I'm going to share out my 16 sweets equally between these 4 groups. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13, 14, 15, 16. And just like with division, I want to teach the children that a quarter of 16 is going to be one of those groups. So four there tells me how many groups I need to draw. And this number tells me, the numerator, how many groups I need to count. On this occasion, I just need 1/4, which is 1, 2, 3, 4. So the answer, therefore, is going to be 4. Okay, moving on. Okay, so page 10 of the test, 19 and 20. Now here we've got 60 adds something equals 89. So they've tried to confuse the children here by putting the box in the middle of the sum and not at the end. Now, once again, I teach the children that symbol there, the equal sign, is like a weighing scale. Whatever is on this side has to equal this side. So if I've got 89 on this side, I need to add something to 60 to get to 89. So let's just try a different method for this. Let's try counting forward. So we're starting from 60. How do we get to 89? So let's say to the children, well, we could add 10. That makes 70. We could add another 10, which gets me to 80. So I'm almost there. What do I need to add to 80 to get to 89? Well, I only need to add 9 more. Okay, and that will get me to 89. So then ask the children, well, what have you added all together? 10, 20, and 9. That makes 29. And it should show that whatever is on this side equals the same on this side. Once again, question 20, we've got a missing number problem here. So we've got a box that needs to be filled. Plus 25 equals 37. So once again, whatever is on this side needs to equal 37. So I'm going to take 25. Let's try that again. I'm going to take 25. Okay, I'm going to draw that at the start of my number line. And I'm going to see what I need to add to 25 to get to 37. So I need to add a 10, first of all. That'll get me to 35. And what do I add to 35 to get to 37? I'm going to need to add a 2. 37. So what have I added all together? 10 and 2 make 12. Another way that they could solve this is using the inverse. In other words, they could have done, using the 10s and 1s grid, if they're confident using the inverse, they could have done 37, subtract 25, and they would have got this answer, the same answer of 12. So that's just another way of them solving it. Okay, right, moving on. Okay, question 21. So for this question, it's 54, take away, subtract 15. So again, for this type of question, I would encourage the children to draw a 10s and 1s grid, which I'm going to do over here. So my 10s and 1s. And what we say is with subtraction, make the larger number first. So 54, we've got 5 10s and we've got 4 1s. So that's 10, 20, 30, 40, 50. And I've got my 4 1s, 1, 2, 3, 4. And now I'm going to subtract 15. So I'm subtracting 1 10 and 5 1s. But interestingly, if you look and show the children here, can we take away 5 1s from 4 1s? We cannot. So at this point, we need to borrow from the 10s column. And what you would do is you would show the children, they would draw this arrow, the 10, borrowing it from the 10s column, crossing it out, and then writing in those 10 1s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we have, we've got 4 and 10, we've got 14 1s. So we now can take away these 5 1s here. So I'm going to cross those out. 1, 2, 2, 3, 4, 5, which leaves us with 1, 2, 3, 4, 5, 6, 7, 8, 9 1s on this side. But what we must not forget to do now is to go back and subtract the 10s. And with 15, we've got 1 10 to take away. So I'm going to cross out that 10. And what are we left with? Okay, 10, 20, 30. So 30 over here. And 9, don't forget to add the 2 parts together, leaving us a final answer of 39, remembering to write the answer in the box. So the next question, 60 divided by 5. So once again, we would tell the children that this symbol here means to share. Okay, so what we're essentially saying is 60 sweets shared by 5 people. 60 shared with 5. Now, I know for some of these questions, we would encourage the children to draw out those 5 groups, okay, because we're sharing 60 between 5 people, and then to share them out between those 5 groups. But that's a very long way of doing it. Some children may try and do it that way, and they may get the right answer. However, it's not the most efficient way. So another way is to think about what do I multiply by 5 to get 60? Okay, so 5 times what makes 60? And the children can count in 5s to do this. So they could count 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. Okay, and they should see that they've counted 12 5s. Okay, it's also really important for them to know their times tables in year 2. So they should be able to know that 5 times 12 equals 60. Okay, and therefore the answer to this question is going to be 12. And if they shared out the 60 into these groups here, each one person would get 12. 12, 12, 12, 12, and 12. And 5 lots of 12 make 60. So, you know, you've got 5 10s, 10, 20, 30, 40, 50, and then you've got 5 2s, 2, 4, 6, 8, 10. So that's 50. Add 10, which gives you 60. So there's quite a few different ways of working this one out. Drawing the dots, sharing them out is probably not the most efficient way. Using your known facts, using your times tables would be the best way to do it. Counting in 5s until you get to 60 and then seeing how many times you've counted 5s. Okay, but 60 divided by 5 would be 12. Now in year 2, they have to know their 2s, 5s, and 10s times tables up to 12. So if they do know them, it should help them with this question. Okay, question 23 and question 24. We're on page 12 of the test. So these questions towards the end are most likely going to be the trickiest for the children. So for this one, I'm going to draw my 10s and 1s grid as before. And first of all, I'm going to start off by making this larger number. So 92. We have 9 10s and 2 1s. So 10, 20, 30, 40, 50, 60, 70, 80, 90, and then the 2 1s, 1, 2. Check the operation. So we've got a subtraction question. So I'm going to be taking away this number 85, which is made up of 8 10s and 5 1s. So first of all, I'm going to try and take away the 1s, which is what you should do, and what the children should learn is to take away the 1s first. Now, as you can see here, and the children should notice also that we can't take 5 1s away from 2 1s. So what we're going to do is we're going to borrow a 10 from 90. So this is what the children would do. They would draw the 10 moving over into the 1s column. And just to bear in mind, this is before you've taught them column method. This is kind of the lead into column method, so they can see what borrowing a 10 actually looks like. And then that 10 then becomes over here 10 1s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we've got 10, 11, 12 1s on this side, and we can take away 5. So 1, 2, 3, 4, 5. Okay, what does that leave us with? 1, 2, 3, 4, 5, 6, 7 1s on this side. But then now we have to take away the 10s. We've got 8 10s to take away, so I'm going to cross out 8 10s from here. 1, 2, 3, 4, 5, 6, 7, 8, which actually leaves us with 0 10s on this side. And we've only got 7 1s remaining, so 7 is our final answer. And don't forget to write the answer in the box up here. Okay, next question.
This question is quite tricky for the children because they have to try and find out what number is going to be in this box. They have the answer, so it's something subtract 50 equals 50. Now, there's a couple of ways of doing this, but I would encourage the children to draw a number line. Okay, and essentially, you're adding 50, you're taking 50 away from something to get this 50 here. So what do you need to take 50 away from to get 50? So we can start off, first of all, by trying to count on. So we've got 50, and we can do the inverse. So instead of trying to find out what we take away from, we take 50 away from to get 50, we could do 50 add 50 to see what this number would be. So I'm going to start with 50, and I'm going to add 50. Okay. Depending on your child and how well they know then number bonds up to 100, they might be able to do 50 add 50 in their head, or they might need to do 5 jumps of 10. Okay, so 10, 60, 70, 80, 90, 100, doing 5 jumps of 10, which would be 50, but they should get to a final answer of 100. So one way of doing this is to do the inverse. Okay, and to add those two parts together, and it gives you 100. The other way would be to try and think, well, what do I take away from? What do I take 50 away from to get 50? So you could start with a number. So this would be trial and error for them. But if they start with 100 and then they take away 50, and you can do this way to just check your answer. 100 take away 50, and you get to 50. So that proves that 100 is the correct answer here. So 100 take away 50 equals 50.
Okay, on to our last question, question 25. Okay, this is page 13 of the arithmetic paper. So we have a 2-digit number take away another 2-digit number. So 66 take away 38. I'm going to draw my tens and ones grid for this one, okay, and that's what the children need to be doing. And first of all, that's step 1. I'm going to draw my bigger number. So I'm going to draw out 66. Let me just get rid of that. So 66, so 6 tens, 10, 20, 30, 40, 50, 60, and 6 ones, 1, 2, 3, 4, 5, 6. And now we're going to take away 38. So that's 3 tens and 8 ones. But again, we can see that we cannot take 8 ones away from 6 because there isn't enough. So I'm going to borrow. Okay, so I'm going to borrow. I'm going to get rid of that 10 out of the tens, cross it out, and that's what you want the children to do. And then we're going to write down 10 ones over here. 5, 6, 7, 8, 9, 10. And now that I've done that, I've borrowed that 10, I can now subtract those 8 ones. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, and I'm left with 1, 2, 3, 4, 5, 6, 7, 8 ones on this side. And now I can take away, not forgetting to take away the tens. I've got 3 tens to take away, so cross that one, and cross that one, leaving me with 2 tens. And don't forget to add those 2 bits together, a final answer of 28. Making sure to write the answer in the box. Okay, I hope you found this video useful. That brings me to the end of the 2022 test. These will be very similar questions to the 2023 test. So do practice these methods with your children to help them when preparing for that test, which will take place in the month of May. Please subscribe to the channel if you haven't already for more videos on primary education as we move towards those SATs tests this year. And thank you to all who have subscribed. We really appreciate your support. I hope you find the channel and videos useful. And please put in the comment section any videos you would like to request about anything related to primary education. I'll be happy to make a video for you. Okay, and that's it. I'll see you in the next one. Thanks, guys.